non-destructive testing, union working, and the blue-collar experience, as narrated by me. So as a basic, what is NDT, non-destructive testing? It's an umbrella term for a wide variety of disciplines which are designed to assess material properties, including damage wear, without causing damage to the subject or system being tested. Essentially, when an object is what is called under load or under stress, you need to check whether or not that object is prone to failure. Non-destructive testing is meant to do that without disturbing the object in a way that could affect its integrity, while still giving you a fair assessment of both the surface as well as the internal. There is a side sister discipline called destructive testing, for those of you already wondering, which is people that do things like take steel and pull it until it breaks to determine things like tensile strength. So, who am I? I'm a Canadian man. I've been in the industry for 6 years. I do something primarily called phased array version of advanced ultrasound. I get certified by the Canadian Governing Standards Board and the British Institute of Non-Destructive Testing to perform NDT in Canada. Under BINDT, which is the British institution that certifies a discipline called phased array, which is advanced ultrasonics, that certification is actually international. So I could do that in Britain, I could do that. My major roles have been all over the place. Phased array ultrasound, before I talk about it later, is essentially the same system that is used to do medical sonography in the imaging of children and fetuses in pregnant women. Now, in those systems, they are automatically calibrated for human tissue in terms of sound speed and frequencies and things like that. The difference for us in the material world is we calibrate each system to a given job, and then we produce data which gives you indicators that tell you what flaws or problems may exist in a part. I also do things with automated UT, which essentially amounts to scanning large areas of steel to determine whether corrosion or erosive forces have removed steel from the far side. So I do things like mag and die, which are surface disciplines, which you can see in the upper right here. I don't know if anyone can see my cursor, but on the upper right, that's what's called a die penetrant indication. In this case, it's a crack along a weld. Die is applied, and then you let it sit, and then the excess is removed, and you spray on something called a developer, which is this white stuff, and it pulls the die back at any flaw that might be on the surface. Methods like that are generally called surface methods. They show you things like cracks and pinholes and other potential failures that that breach the surface. I also fly drones, and I drive robotic systems. My specialty at work is sort of the general troubleshooter, and I'm very good with interfaces. So anything that basically has a remote control or some sort of digital software panel that has to be negotiated with, for lack of a better term, is something that tends to be very within my wheelhouse. In that same vein, I deal with emerging technologies. Anything that is new and strange is something that I tend to take a real interest in. And then behind that is some fundamental NDT that I do quite a bit. I also do a lot of training of newer technicians, assistants, what are called scanner techs. So if you take medical sonography as an example, the scanner tech equivalent would be if you had one person operating the probe itself on the stomach of the person you're scanning, and then someone else is analyzing that data afterwards. In our case, we scan data in the field, have a scanner tech operating your crawler robot for you, and then you are reviewing that data as it comes up. I also do things like explain safety paperwork, explaining safety systems.
All right, hold up for a second here.
I do a ton of field training of technicians. I have a lot of responsibilities when I have an assistant, because depending on how new that assistant is, I need to do things like walking them through safety paperwork and letting them know about things generally called life-saving rules on various sites here in Canada. Those are listed in terms of things like line of fire, permitting, and things that basically keep the energy that we deal with and the systems that we deal with from hurting us. So that's another significant portion of what I do. NDT disciplines, there's a whole bunch of them. Basically, I know how to do, I think, 5 or 6 of these. I'm familiar with the rest. They're not all the same. you can obviously read along with me. Basically, it's dependent on what you're inspecting, what you're looking for. Generally, engineers are more familiar with what damage mechanisms are actually going to occur in a given piece. So if you think about a paper clip, for example, a paper clip, when you fold back and forth, is going to break in half. Before that, even if you can't see them, you're going to build up stress fractures in that steel in advance of it breaking. Engineers would be able to basically say the damage mechanism of a paperclip is people like to bend them back and forth until they break. Ergo, we should look for cracking in the portion that's going to bend. It's sort of the rough gist. Each of these disciplines does various things and searches for various inconsistencies that would lead to failure later in the object's lifespan. And we do this from the point of manufacture. So there's some things that can exist right from the beginning. So if you look to the radiographical testing, which is the second from the top on the right, you can see that's actually a weld as viewed using ionizing radiation. So the same as like a bone X-ray, except much, much more powerful to punch through steel. And you basically look for defects in that. Each of them has their own different array of experience, certifications, exams, things that allow you to do it in a way that is safe and effective in terms of delivering the quality you want for the inspection you're doing. Especially given that a lot of the stuff we deal with is infrastructure as well as aviation, things like plane parts or bridges. You want to know that the people that are doing that work are doing a good job. Also, generally speaking, when I kind of explain what I do and what role we fit into in society, everyone is generally pretty glad that we exist, although generally speaking, nobody knows we do. The bottom two disciplines, as I mentioned in my slide, are actually just extensions of the upper two. So phased array ultrasound is essentially a more complicated version of ultrasonic testing. Essentially, rather than sending one signal through a piece of steel and receiving an echo to determine thickness, you are sending it any number of ways with any number of beams to paint a digitized picture of the internal structure of a piece of steel. Radiographical testing is an approximation of the same thing, except using X-rays to shoot through steel. Let's see. NDT beginnings. Where did it come from? Essentially, stuff would break and people didn't know why. That's kind of the gist of it. In the 1800s, it was something called oil and whiting. So basically, they would spread hot oil on a railroad rail and then wait and then wipe off the excess, similar to the dye penetrant I mentioned earlier. They'd allow the oil to seep into any cracks or flaws within that rail. And then the removal of the excess and an addition of a white coat of paint would bring out the oil from the part and be able to see things like cracks and flaws and things that would go on to disrupt in the future. Essentially, there were a lot of things they could see. And if a train rolls over your railroad tie, that is the first time that railroad tie is going to experience the kind of load that it needs to experience in operation. So what you want to do is you want to find the thing that could potentially cause a failure long before that. At the end of the 1800s, a guy named Wilhelm Röntgen invented the X-rays, which would later go on to be used for flaw detection. I think it was 40 years-ish later. And similar to humans, when there's an issue, you shoot an X-ray through it. It shows you a bit more than you can see just looking with the naked eye. This is also just a photo showing that we've been around for a long time under various names, but the same principle. We're trying to find broken things before they break, because after they've broken is generally too late. Modern NDT. So we have things like fluorescent mag, which is this green gear that you see here. Internal drone inspections. This is something called an Helios 2. This is actually the one I've flown in the field. The main benefit of having an inspector flying a drone as opposed to a drone pilot flying a drone is simply that drone pilots are very good at getting big cinematic shots and they're very good at controlling a drone, but they have no idea what they're looking for. So you can get a big cinematic shot of some asset, and it'll be fantastic. And you could probably put music to it, but they will entirely miss the point, which is to check, XYZ nozzle for this type of flaw or this type of internal mechanism that's going to cause it to fail in some amount of months. Things like digital radiography, that's been a more recent advancement as we figure out how to integrate computers with the things that we deal with. And then obviously on my part, phased array ultrasound, which is something I do day to day, and have been doing actually for the last 10 days. So the industry itself spans a number of sectors. We're pretty much everywhere. As I said before, materials under load are really common. Anytime you have any item, generally steel or stainless steel or aluminum, anything that is under load. So as an example that I use quite often for the people that I teach, baking pans that you use in your house are not going to get NDT tested. They are not under the kind of load that would cause a problem if they are put under sufficient stress. But something like the tie for a bridge or a railroad tie or a pressure vessel or a piping system, any of those things where the risk is significant in terms of things like explosions, chemical releases, environmental hazards, all of those have a given amount of NDT inherent in both their building and their maintaining that is dictated by things like codes, engineers, and various other legal doctrine that exists in both Canadian law, American law, and abroad. Yeah, so yeah, this one I just got it. I tried to get it to generate a photo of an NDT god, and this is what it came up with, and I thought it was funny. So, unions. I know Jester had talked about this with me in terms of asking about how we have multiple unions. A big part of this is that there are not very many of me. Um, I am in the 25,000s number wise. We all have a designation given to us by the Canadian Governing Standards Board. The number is in the 25,000s for me specifically. That is dating back to something like the 70s or 80s. I meant to research this and I didn't, but it's essentially there's only a few thousand of us active in the country at any given time, which makes sense. It takes less time to inspect a weld than it does to weld it. So, depending on if you needed 10 welders, you probably only need one of me. So, there's not very many of us. To that end, it's much harder for us to argue for our own benefits because there's not very many of us. So, a while back, we merged with two specific unions, which is the Union Association of Union Plumbers and Pipe Fitters and the International Brotherhood of Boilermakers. The reason there's two different ones, I think, stemmed from the fact that we had different goals, and each of those unions serves different purposes. The Boilermakers tends to have more benefits in regards to travel. You pay higher union dues, but the benefits tend to be greater. And then the pipe fitters is more aimed at people who are in town. There's less of a travel benefit. The union dues are lower. So you can kind of pick your poison of sorts in terms of either or. I'm very pro union. They have done a lot of things like argue for better wages and better working conditions. They actually put out a notice. I'm part of the union on the right. I'm a member of the International Brotherhood of Boilermakers. And they put out a notice about a day ago that said, in regards to two-factor authentication on phones, that your company cannot make you install a two-factor authenticator on a personal phone. So things like that where it gets brought up, the union argues for things like our rights, our safety, our wages. It is not without its criticisms. A lot of people make the complaint of why should a great, ultrasound technician make the same amount as a terrible ultrasound technician. I would argue that I would rather live in a society and function in a workforce where there isn't a subset of employees that are paid pennies on the dollar. Even if you could make some argument that they are sufficiently worse than any other person, I would argue that the amount of hours each tech is given is generally reflective of their skill set. And so to that end, the techs that tend to work harder and put in more effort tend to receive more hours and by extension more money. I didn't have any other slides beyond that. I had meant to make more, but I guess I'd kind of tell you guys what I've been up to for the last few weeks, and then that would maybe go some ways to explaining it. So I will just duplicate this slide. I don't know if you guys can still see this though. Hang on.
No, we cannot. You can make it.
I'm just going to add this because this actual presentation I had wanted, I probably will use at some point um, in terms of going to something like a job fair, which has been talked about before. Because I do a lot of this, both with trainees and other people. I've spoken at the university in the city where I live in Alberta, to things like students at the local polytechnic, as well as students at the university, in terms of what I do, trying to motivate people to do this because it is a small trade, and there are not that many of us, and we could really use some more because a lot of the people that are doing this now are older, and we're going to lose them in the next few years. So this is a slide called "What I Did This Week" because I think it is relevant. So the reason that I haven't been working on this PowerPoint as much as I'd like, and this slide is 6 long instead of something like 10, is because in the past 10 days, I think I have worked 130 hours. The reason for that is a failure on a steam line, just as an example. So in the case of what we have here, there has been a failure in a system. In this case, it's a steam pipe, so it carries steam, and it broke open. Now, the relevant powers that be and the governing bodies that dictate what you can and can't do have said this item cannot be run again until you have inspected it. That is where I come in. I basically show up, I inspect XYZ part, whatever it is, and I deliver a report, which is then given to their engineers. The engineers formulate a report to say, this is what the condition of the item is. This is why we believe it is safe to continue to run. This is what we have done to repair the issue that we had. And then they present that to the regulator, who gives them a yes or no to turn that system back on. The reason I'm working that many hours is simply to get the job done. We have very robust overtime protections, so I'm paid very well to work past 8 and 10 hours a day, including things like time and a half and double time, and living out allowance for travel. As I said just before the presentation started, I'm in a hotel right now. I've been in a hotel for 9 days. I spend probably about 100 nights a year in hotels, traveling around Alberta and other parts of Western Canada. I have coworkers that have gone as far as Australia to do inspection work, still working under the same company's umbrella. So there's lots of opportunities to travel and see new things and experience a lot of stuff that I would not otherwise be able to do. So I'm very fortunate. It's a very cool job. It is very demanding, and the fun bit is I like to say that my word is law, in the sense that when I say something is good or bad, there are legal ramifications to that, because ethically you want to know that the systems that you rely on have been checked. So yeah, now I will open the chat up to any questions and stuff. And yeah, if anyone has any thoughts or comments or queries, then by all means.
Awesome. And the chat you can access by pressing that little open chat button. If you scroll over in the channel list, the opens the stage, you can open that, or you can probably access it on the right side. I don't remember how you do that. Hold on. Yeah,
Oh,
it's just
perfect.
press the little show chat button at the top right. Um, and so feel free to ask any questions about whatever. So first of all, how do you become an NDT Tech like you are? Like what training have you done to do what you're doing right now?
So this actually bothers my secondary education friends quite a bit. I'm actually a high school dropout. I never particularly liked school. I did skip a grade, so I was never overly bad at it, but I never had a particular affinity for what I felt they were teaching me. I've spent a total of 7 weeks at a polytechnic. Each of those tickets and disciplines has a given amount of coursework. generally in a 1 or 2 or sometimes more week span, but usually 1 or 2, which means 40 hours a week of dedicated study time towards a given method. You then need to work in the field for a set number of hours for the what are called the surface methods, or generally speaking, the simpler methods. It's about 500 or 600 hours. Um, that is going to allow you to write the exam, and that combination of exam, work hours, and course allows you to get what's called a ticket, and that is like your magnetic particle ticket or your phased array or whatever it is. Some of them have pre-qualifiers. You need to get a UT2 or an ultrasound level 2 in advance of getting a phased array, so on and so forth. So there's steps in the ladder. But yeah, so I went to courses. My dad did this in the 80s in order to pay off his master's degree. That's how I know about it. Generally speaking, anyone who's entered this industry has some sort of connection, either friend or family, who has told them the industry exists to begin with. Um, but yeah, that's how I ended up here.
And how many disciplines are you trained into? Like how much work have you done to actually, get here?
I would say that by virtue of the fact that I'm pretty tech savvy, I do, formally speaking, I'm certified in 5 methods, which is essentially material identification, which is a radiation gun. You can search X-ray fluorescence, as well as magnetic particle testing, which is essentially inducing a magnetic field into a part in order to draw magnetic material into a crack, which produces an indication. So if I went back to my little slides here, I think you guys can still see this. Um, this particular discipline, oops, is inducing a field which then draws in the magnetic particulates into the crack here, and then you can see it. And then our job is to both recognize that it's a flaw and then size it and judge it to a given code. So I do that. I do uh, mag, I do dye, I do phased array ultrasound. Advanced ultrasound is a big part of what I do. My background playing a lot of video games and also being generally pretty good with staying calm in difficult situations is why I fly the drone. Um, you basically can't panic when you have a $60,000 piece of equipment hanging 40 feet in the air and it hits a wall or bumps into something. You can't freak out and start hitting every button on the controller, otherwise you're going to break it. So same thing with the robotics. They're expensive systems. You need to be able to recognize that and still use them. Like you can't let them control you, but you still need to be aware that the decisions you make are going to affect either the integrity of the asset you're using or the asset you're inspecting. Breaking either of those is generally bad.
Okay. Yeah, that makes sense. Um, and so you train so you train into a lot of things. Do you say the average NDT tech is also trained into that many things, or do they usually go deeper into one thing?
It really varies. There's a few techs that do things like singular methods. So you become an ultrasound technician and you become what's called a level 3. Most disciplines have between 2 and 3 levels. Generally, your level 3s are people that write the code and essentially the rules of engagement for how to do a given discipline, what equipment should be used, what temperatures it should be used at. So all of that governing documentation is generally written by level 3 ultrasound folks. Level 2 is generally your more senior inspectors in the field. So like myself, those are the people actually doing the work, determining whether or not things are failing versus not. And then we report to a level 3 as needed if there's ever any disputes or questions about code work, things like that. Oh, and to answer your original question, because I got sidetracked, the average NDT tech does not do as many things as I do. The average is probably between 1 and 3 tickets, like mag, dye, and ultrasound sort of thing. The reason I do so many is because I work in the sort of specialized sector of my company, and they basically deal with all the expensive and weird stuff, and I happen to be generally pretty good with expensive and weird stuff and communicating it in a way that makes sense to clients. So if someone in the field is coming up and asking, why are we using a given system or how does it work, there's uh, there's quite a bit of thing. There's quite a bit of stuff that I could say on any given subject um, that will help make it make sense to the people that aren't very familiar with it.
Okay. J Squared asks, where do you see the future of the industry going? How do you think the lack of new hires will impact things long term?
I think that the future of the industry is going in a generally good direction, with the exception of the second half of your question. The industry is growing in terms of both workflow and work scope as more and more disciplines become available. Companies have realized more and more that the amount of money they save far outweighs the amount of money they spend, even for expensive disciplines. So, for example, the cost to hire me and an assistant and my equipment for any given day, say for like a 12-hour day, which is a fairly ordinary day, is something like $4,500. It's expensive. But just as an example, some of the systems I've worked on in the past, we are billing, $4,000 or $5,000 a day. But the system that we are working to try and put back into service is losing that company $50,000 a day. And so the cost for the companies is far better to pay me a significant amount of money as opposed to an exorbitant amount of money for loss of production, generally of fossil fuels. Though I do work in other sectors, I work in things like fertilizer, um, plastic manufacturing. Pretty much every sector has metal, and almost all of it is prone to failure.
Ibra asks, I'm going to actually add on to something to this question, but Ibra asks, so I just wanted to ask, what would be the repercussions of giving a bad diagnosis report that might have caused a system failure or something of the sort? And I also want to ask myself, uh, have you ever seen that happen? Like, and if so, how often does it happen?
So generally speaking, it is very rare. There is something called an ethical code of conduct, which is a big sheet of paper that you sign when you first submit your applications to do a given method, and then it's kept on file by the people that govern all of us, which is Natural Resources Canada, or NRCan, and that basically is a document that says I will do right by essentially the world in my efforts to do my job. You're not going to act in your own interest. You're going to act in the interests of the well being of the people around you, which is a good thing. It is not always held to. There are lots of stories that you hear, especially in training and in school, about people that will do things like falsify documents. If you go to the directory of certified personnel, on the NRCan website, you can actually see a list of actions and things that have been taken on people that have done wrong in NDT. Um, Specifically, exam based things are a big one. So, people cheat on an exam, they tend to lose a given amount of certification. You usually can't go back and redo that exam. If you do things in the field, the punishments are much more severe. We don't generally want people to be falsifying documents. It can lead to things. I would say in advance, making mistakes is different than negligence. If you are found criminally negligent of, for example, falsifying a report or saying something was good when it wasn't, or being paid to say something was good when it wasn't, you can lose your certifications for life. You can be barred from the entire industry. Your reputation will be ruined, which in a small industry is a very big deal. You can be criminally liable if you were found to have done it on purpose. But we're all human, right? We make mistakes, we miss things, and there's errors that do occur naturally that are not treated with nearly the same punitive action that something like a forced error or a purposeful mistake would be. In terms of a system failure, it's just bad. Like there's no two ways about it. Like there are jobs that I do where I am understanding that if I make a mistake and I'd say that something is okay and it's not, and they turn it back on and they put it under 3,800 psi and it explodes, it could kill someone. That's relevant. That exists in my brain and it should, because the work that I do is important. And also, when I'm walking around a large site full of piping that is full of chemicals and all sorts of things that can kill me, I am relying on the people that walked in my shoes before, on the fact that they did a good job and an honest job. So there's a lot of pride, I think, that is not necessarily inherent to every tech, but I think myself and also a number of other techs that I know, where we do take a lot of pride in our work and the fact that it essentially prevents harm, which is a nice feeling. We're not like firefighters. We're not necessarily, the big brash and brave, but we like to think that the work that we do helps people, which is cool.
Ibra asks, you mentioned levels of NDT techs. Do you need a certain degree or a certain certification that allows you to rise through the levels, through the levels, or does it just come down to experience on the field?
So, like I mentioned earlier, I'm a high school dropout and proud of it. I think a lot of people may regret that. I personally don't, but obviously hindsight is 2020. Um, I'm going to expand into this with J Squared's question, which is, do people get hired by an NDT company or an NDT department in a company, or is it more like contract or freelance work? I'll sort of tie those two questions together. You don't need a certain degree. You do need a certain amount of time before you can write an exam. You also tend to need a certain amount of experience and to be able to demonstrate that experience to a company. So we have things at our company called an SNT, which is essentially a company side exam. So even if you have the certification from the national governing body, the company that you are working for still wants to know that you can do the thing that you say you're going to do. It's sort of like your driver's exam means you can drive, but you still need a test to work for a trucking company. Um, in terms of the do people get hired by an NDT company or an NDT department, it's a bit of both. A lot of major like things like oil field companies or aerospace companies have their own NDT departments. It's pretty rare that you just get hired directly into one of those. Usually, you'd have to have the certifications first. In terms of singular NDT companies, you can get hired on as a trainee with no qualifications whatsoever, and be a general sort of gopher, learning, working alongside technicians. That's kind of what I did. I did the courses first, then I got hired at my current company, and I basically worked my way up. I seemed to have a pretty good affinity for computers and fixing things, and so I was brought into the department that deals with more expensive and more complicated technical stuff. Um, and then by extension, the fact that I can seem to maintain a pretty cool head under pressure means that they trust me with things like the drone, robotic crawlers, and other stuff that is more, you need to have a certain amount of patience and a certain amount of thinking on your feet, or else bad things happen. So I hope that answered that. Oh, actually, sorry, I'm going to double back to the lack of new hires question, which is, it's not going to be good. If there are no, if long term we don't have enough new hires, the entire industry is going to suffer, and you're going to see things like companies not being able to restart, or worse, potential for an increase in workplace accidents because there are not enough people to inspect the systems that are producing the oil or gas, or systems that, for example, like water. I've inspected water piping, like main lines for the city I live in, things like that. If you have to push out what's called an inspection window, which says, my water main's going to break in 5 years, so I should inspect it in three. Maybe they push it to 4 years because they can't get a person. That's a bad thing. So companies are slowly trying to figure this out and motivate people because we just don't have enough people, especially for the more advanced disciplines, where it takes quite a bit more effort and time. And I think if more people knew about it, they'd take more advantage of it because it's incredibly lucrative from a financial perspective. And yet, I'm sure that a lot of the people that, for example, do engineering degrees could do what I do without too much difficulty if you have that same amount of sort of math and science proficiency.
So you're obviously Canadian. Do you know what it looks like in America? Like if you wanted to do something like you're doing, how would that work in America? Is it a similar process and structure, or is it very different?
It looks almost exactly the same. The main differences is that you are certified under a different body. You are certified under ASNT, which is the American Standard or American Standards of Non-Destructive Testing, I believe is the acronym. But the company I work for operates a huge division in the United States as well as a Canadian division. Um, the work is largely the same. A lot of the stuff that dictates how we do our job stems from the United States or vice versa. Um, so it's fairly similar. The union structure would be a bit different, depending on where you work, whether or not you work for a union or non-union company. I should have mentioned not all NDT is unionized. There are non-union companies you can work for, and yeah, your results may vary. The whole point of the union is to set a floor on which everyone can stand, which is a good thing, in my personal opinion.
Okay. Um, Earlier you mentioned kind of the lack of new hires and the issues that may arise. Do most companies are they doing this because like did they set their own standards for when inspections and everything happens, or is it most of it required by some sort of general body or the government or something like that?
So there are a number of institutes that dictate how often something should be inspected. Certain parts is inherent in the system. People like oil and gas producers, Suncor, Syncrude, they want to know that their equipment is going to keep working. So they're going to have inspection schedules on their own no matter what, because their equipment working means they're still producing oil, which means they're still making money. So they have a lot of personal investment in that. There's no this idea that they're completely, like this. It's true. There's a lot of media that talks about pipelines. Pipelines are actually one of the safest ways to transport oil. I should say before I say this that I'm still very pro green energy. I think we need to de-oilify and so on and so forth. It's just this is where I happen to live. The oil industry has a big impact on my day-to-day livelihood. Ideally, in 10 or 15 years, maybe that would change. But these companies have investment in things like pipelines not failing. On top of that, there's things like ABSA, which is the governing board for things like pressure vessels and tanks. They basically dictate how often you have to inspect a given pressure vessel or something that's holding a liquid, depending on what's in it. If it's something caustic like hydrogen sulfide, which is very prevalent here, it's a poisonous gas that comes from the breakdown of organic material. If that's in the line, it's corrosive to steel. So it means that your inspection frequency, basically how often you check in on it, goes up. So think about it like having a pie in the oven. The hotter the oven is, the more frequently you have to check the pie to make sure it's not burnt. There's a sensibility to it that comes with just generally knowing how to cook a pie, but also there's going to be people that know how to do that and can tell you how often you check it.
Okay. Okay. And you mentioned there that I mean, obviously, a lot of what you do is on pipes. With the kind of necessary phase out of a lot of different natural resources that are creating climate change kind of happening the next 20 to 30 years, is that going to impact your job a lot, or is it going to, is it going to be replaced with something else, or is there enough stuff to do otherwise?
There's actually going to be a huge amount of work for me by virtue of the fact that the industry is changing. So, just as an example here, we'll show this bit of Google here. So this is a wind farm in Halkirk, Alberta. These are giant windmills. Um, they basically are, I think the blades themselves are 80-meter blades. So this is about 300 feet in the air. One of these, I did an inspection on one of these. Essentially, what had happened is the rotor had gotten locked inside the motor that is in this. For reference, this is about the size of a school bus. You don't realize until you're in it, but they're huge. And the rotor had basically caught, and the propeller kept spinning, and the engine didn't want to. So it feared through about 16 inches of solid steel and snapped 90-inch diameter steel bolts and basically tore the entire thing free. Imagine an entire engine in a car ripping every connection that holds it in place. And that happened inside this. And then I had to go up and check the chassis and the base metal that that engine had been mounted to see that it hadn't been cracking and it wouldn't produce a problem in the future. So there's metal everywhere in solar panels, in wind farms. We have guys that do things like hang off of these and inspect the fiberglass shaft that runs down the outside of this. As soon as it's made of metal and it is, big enough or heavy enough or under enough stress that it matters, we have to look at it. So I have no worries at all about our hopeful transition to green energy in terms of my job. Um, there's no denying that I benefit significantly from being where I am and fossil fuels being as prevalent as they are here in my particular part of the world. But I do hope that we can move towards more of that stuff, and I have no worries about job security into that sort of future. You can go in them, J squared. You can absolutely stand inside a wind turbine, um, inside the top of wind turbine. Yeah, so they look like this. There's a whole thing, a tube with an elevator if you're really lucky. This is a good version of what I did. I stuck my head out the top. The wind speed at the time was a bit too fast. I wanted to strap on a harness, which is basically a fall arrest system that prevents you from falling to your death. And I wanted to tie myself off to the top of it and walk on top, but it was like 50-kilometer-an-hour winds, and they wouldn't let me. I'd also add for anyone that ever gets offered that. Yeah, there, the Tom Scott video. So I would also add for anyone that hasn't done that, if you're ever offered it, know that it will make you incredibly nauseous. The tallest ones of those flex about 8 meters in either direction uh, in the winds that they're under. So it's basically like being on a big ship that's swinging back and forth. It can make you really ill. So a grain of salt if you ever have that opportunity. But it was very cool. I highly recommend that. And the guys who do it all the time, they have sea legs of sorts for standing up there.
All right, we're gonna wrap this up with two more questions here. One from On. Do you have a worst close call story? And if you don't want to share it, we understand.
Um, I don't know. It's difficult sometimes to have a close call just because what we do, if we miss something, we don't necessarily find out for a while afterwards. I've had a few things. I'm not at liberty to talk about clients and things like that, but I can say that at one point, I flew a drone inside a large tower vessel, and I had it on a fishing line, and then I got it looped around a thing. I wonder if I can show this in paint. This would make a lot more sense. So I had a drone on a fishing line in a tower, and in the course of flying the drone, I got the fishing line tangled, which meant, unbeknownst to me, when I was at the bottom of the fishing line, trying to hold on and figure out what the heck was going on, the drone was upside down. So there was this giant lanyard, and then me, and then the drone. And it was caught on something somewhere up here, which means the drone is pushing this way. And so I can't see any of this because it's flying upside down. And if you draw your physics diagram, the air is pushing up, gravity and this string is keeping it stable while it's flying upside down in a cloud of concrete because this was a concrete dust plant. Um, so that was a I flew it out an open manhole at like 30 kilometers an hour upside down into my assistant's hands, um, and thankfully did not smash a $60,000 piece of equipment. In terms of like dangerous close calls, thankfully no, none that have ever happened to me personally, which is very fortunate. I'm very safety conscious. I'm very aware of guidelines and rules, and I try to wear every single bit of kit that I can to keep me safe. And I do the same for my assistants because this job matters a lot to me. I have a lot of hobbies that I like. I like to go and travel. I like to do things like watching theater and plays, and this job facilitates all of that. So I think, be very irresponsible to not take personal safety and the safety of other people pretty seriously as a part of that.
That's very cool. With the drones, do you just fly them? Like, how do you fly a drone like that? Do you have a camera on it, or like is it just like by hand? Like how does that work? 'Cause I've seen something with like the VR like drone headsets and stuff. Do you use those?
I do not use a drone headset. I get asked a lot about the drone just because I think the drone is something that a lot of people have as sort of a touchstone for the extra modern digital age and this extension into this sort of futuristic thing that we deal with in terms of like it's one of those buzzwords: drones, VR, AI, and it grabs people's attention. I think also because a lot of people aspire to be something like a drone pilot in their lives, so they hear that someone does that and they think it's fascinating. I fly this thing, which is called the Helios 2. So it's essentially just a little handheld controller with a screen on it and a tablet, and I just look at it and I control it very similarly to any game that might have a flying thing in it. The main difference is that this has no GPS, so it's not like your run of the mill outdoor DJI drones. If you tell it to go forward and then you don't tell it to stop, it'll keep going forward forever. It doesn't know. It's also not a drone you need a certification for in terms of airspaces because it's internal. So it flies inside of things. Same reason it has a cage. It does things like look for corrosion in the roof of tanks. Um, on a given job last year, I think I found about $900,000 worth of repairs with one of these. Um, but this is an example of the kind of footage you can see inside various systems, and yeah, so it's pretty ordinary. The main thing is just if you start bumping into walls and stuff, you really need to be aware of the fact that patience, uh, while it isn't always your friend, taking that extra half second of thought can go a long way in saving or salvaging a job. And by the same token, contrarily, thinking on your feet and recognizing what the problem is in a given moment and dealing with that problem quickly can also save your bacon. So it's a bit of both. Generally speaking, I would say it's a lot like a video game, but if you crash, you've just thrown 60,000 US dollars out a window, which is a lot.
We're gonna wrap this up here because Aatrox is now live. Two. I said two questions earlier, but two questions. First of all, what's your favorite part about your job? Um, what do you enjoy the most?
What I would what I do matters. What I do matters a lot, and that gives me a lot of satisfaction. It's not to toot my own horn, but the fact that there are systems that are in place and running now, um, in some tiny part because of the work that I do, and it helps produce the natural gas that keeps places like where I live, which is middle northern Canada, warm. Um, and the people that do my job in the aviation field are one of the reasons aviation is one of the safest industries on earth. There's a lot of pride there. Sorry, what was the second half of that?
That answered the question. Um, Last question, and I know you have talked for a while about this, so I'm going to ask you to keep it relatively short. But if someone was interested in becoming an NDT Tech, either in Canada or maybe in the United States as well, what should they be doing right now?
I would say Google it. Google it. Reach out on LinkedIn to your near neighborhood NDT company. There's lots of mom and pop shops. There's lots of bigger companies. There's lots of people on LinkedIn that tag NDT every which way on their profiles that you can talk to. Reach out to me. I'm happy to answer questions beyond the bounds of this lecture. I do not guarantee that I will be able to answer them super quickly, um, such as Ibra asked, the work-life balance, all over the place. I don't know. I worked 130 hours in the last 10 days. Some I don't work at all because I won't have lunch. It's really all over the place. So, you know, go looking. We're out there. There's lots of information. So, thank you for watching. This was more chaotic than I had meant it to be, but I hope everyone enjoyed it.
That's okay.
I like
Thank you
talking.
so much for being here, and thanks to On for recording. That's all we have, I think.